Okay, we need to create own application using by Unique SDK. What are we need to do first? Okay, we need to find our library on Maven Central. It's on a type, a repository where I store our library. How we can find it? We can type network unique. And as you can see, you can view free library: Unique SDK Android, Unique SDK Java Signer, and Unique SDK JVM. We need to take only two libraries, JVM and Java Signer. It's provided as Maven dependency, as Gradle dependency, short Gradle dependency, and more. We need to take Gradle short for our Android application. What we can do with it? We copy this text and go into Android Studio or any IDE integrated development environment for creating Android applications, and we're going to build Gradle. What are we seeing this there? We see dependencies section. We already have two libraries from Sonotype. When you add this to library, we need to update our Gradle project. How we can do this? We press sync project with Gradle files. Please check that your libraries have this version or more. You can view, you can see latest version on Sonotype is here. Okay, we imported our libraries, and how we can to do something. After library importing, we can access get object Unique SDK with. How we can start to do something. First, second step. Okay, we need to create signer. What's signer? Signer is an object who can sign your transaction locally on your device. This function implemented by native library based on Rust, but you don't need to think about this because it's wrapped in native library and it's working.
So if I can jump in here, the signer would be the situation where you have, using either MetaMask or some other wallet, when you get that pop-up that you need to execute some extrinsic, you need a signer to confirm that you are allowing this operation to happen on the blockchain. So we need to create that signer.
Yes, thank you. Okay. If we want to create signer, we need to take or seed or something passphrase with password. Also, if we don't have a seed and password, we can generate a new signer. But
let me just jump in with this. And this seed comes from creating an account in a Polka.js wallet, for example. Yeah.
Yes.
So you would be creating on the Opal network. You would be using the Polka.js extension and creating a new account. And it will ask you upon creating the account to place somewhere or write down these seed words because they give you access to the created account. What does this mean practically? This means that this seed is actually the one that identifies a wallet, and that means that we are creating a signer based on a wallet, your wallet.
Yes, thank you. Okay, we can store this seed if you want to. Storage helper is provided on also by our library on your Android device. It's stored securely. You don't need to secure this data. It's already secured. How we can store it with storage helper set data. What's this storage helper? It's a password storage helper object. We can create it by where and use set data and get data methods. Set data with key seed or something else, so we can store our seed and get by key seed and we take it. Okay, we created a signer wrapper and we can sign our transaction locally in future. What we need to do next? We creating GetObject Unique SDK. What is Unique SDK? It's a GetObject with all services for our API. Unique SDK, it's a wrapper for API. You don't you don't need to think about how to call API paths, how to transfer object, how to encoding it to JSON and parse the response. You only need to invoke our methods in Unique SDK and you can using it.
And this step would be initialize the goodness.
Yeah.
Yeah. So that's the first step, the initialization.
Okay. We need to assign our local signer to Unique SDK GetObject to field signer wrapper, and signer and Unique SDK now linked for future invocations. Okay, firstly, let's try to transfer some balance from some address to some destination.
Can I jump in for a second? And the reason why we're connecting the signer to the Unique SDK object is because this allows us in the further code to automatically have the calls signed, the extrinsics, these calls that we're going to be making towards the blockchain. Since when we do this step, it works magically from that point on, and we don't get bothered with like, do you want to sign this? Do you want to sign this? Do you want to sign this? We've set that there.
Yeah, thank you. Okay, it's need to sign locally our transactions in maybe. I tell about it later.
Yeah.
Okay. How we can transfer some balance? Okay, let's see. We take balance service as balance service. Every service can hold our other services or other functions. With services in inner service, call it mutation service. Mutation service, it's abstract interface who can build our transaction, get fee for operation, sign our operation locally, and submit this operation. Invoke one submit operation, provide to you build transaction, sign transaction, and submit transaction. 3 steps by one invocation. It's super. Okay, create our body for transfer. We have address from, and we have address to, and some amount, big decimal. We created our transfer body. What's next? We need to invoke method build with our created body. After this, we got a response from API. We map with response to sign body locally, send send fields from local signed response to API, and we can get by this some hash, and we can see our transaction in Polkadot blockchain by this hash. But this structure is more complexity. We can to do with more invocations later. I tell you about this later also.
So to reiterate, we're packaging the request, we're explaining how we're setting what we expect the response to be, the structure of it, and we're picking up the response in a structure, the sign body.
Mm-hmm. Okay. How it can be viewed? Okay, let's start.
Oh yeah, and where do we get the tokens from? Please mention the faucet because you essentially need to put in some Opal into that account for the transaction to happen.
Mm-hmm. Okay, I create a dummy application when we can press next button and take some transaction hash. We can view transaction hash getting by invocation with. Let's see our application. We can comment this. It's not need more. And uncomment seconds. What this is? This is a section with collection creating. What is collection? Collection is a structure which we can create. We can create a token in this collection and transfer some token to something to somebody. How we can create our collection? We need minimal data, our address, name, description, and token prefix. It can be created simply by invoke submit wedge method.
One comment about the token prefix. It is usually a 4-character kind of ID. You have the complete freedom to choose whatever letters you want to, regular letters, ASCII and numbers, which you might want. And it doesn't matter if they already exist because they're an identifier for a certain collection with an address. So it can be something that was used before. Don't worry about it.
Okay, thank you. Okay, let's test with code. We also can view this first fragment dummy application, and after press next button, we can see two transaction hashes. Okay, first for collection and second for token creation.
You uncommented the token creation as well. Yeah. Nice.
Yeah. Nice. Okay,
we'll just run through it. So the reason, of course, that there are two signatures there is because when we uncommented it, there's a certain section of the code that Stepan will show you now, which is actually the next step, and that is creation of the token in the collection.
Yeah, and after this, we can see on the blockchain some collection with with name and with token prefix. Also, it's owned by me.
Nice. That's our Swagger UI. We need to remember to give the developers the link to the Swagger UI so they can do the checkups with that.
Yeah, we will provide this link after.
Excellent.
Workbench. In chat, maybe. Zoom.
Yeah, I think we can use the Discord channel as the place where we can. Yeah, and also the Telegram chat. Why not? Both places. Yeah, sure.
Okay. And after collection creating, we can create our token. But when we creating token, we don't need always create own collection. We can use our collection for this. You can create own token in our collection. How we can create our token? We also need address. We need to provide collection ID for this token must be linked with collection ID, and we need to provide some data where is image required. Every image in blockchain has IPFS seed. How we can get this? Okay, we need to go to Swagger or use Unique SDK Kotlin library. I tell you about this later. Okay, how we can upload our image? We need this v1 IPFS upload file presses, and you can press try it out. We need to upload file, and you can choose something, open, and press execute. After this, you get response with seed, full URL, and file URL. Get this seed. Okay, and after this, you can see also transaction hash, which you can use to find current transaction and take your token and transfer this token to somebody. How to transfer token? Uncomment this. Transfer token creating similarly by transfer token request. We need to provide address to collection ID and token ID. Token ID is unique, yes? Philip.
Yes, token ID. Yep. We're using the one that we created, the 4-letter one.
Every token started with first, and after creating our token, we can get ID by search in Swagger or Unique SDK and provide here collection ID and here token ID.
Oh, no. That's collection ID. That's the index number. That's not the 4-letter character that we made. Sorry, I made a mistake in because I was reading it. Yeah. That's the index number, if I understand it properly. Yeah.
Oh, okay.
That's the first, the ID, the first of the tokens in the collection.
Okay. And after this, we can transfer token from address to something address. And at this case, I transfer token to me, and I can't invoke this action because it's transferring to me. Yeah.
And what is the return? What are you expecting there in the hash?
Expecting hash, we can see. One moment. We comment this and trying to invoke this. Okay, I press next. And it might take hash. Yep.
It's a transaction hash, yeah?
Yeah, it's transaction hash.
Yeah. Okay. Got it. So we can use that transaction hash on our scanner to actually find the transaction that happened and so on. But
yeah,
that's the point. I just wanted to make a note if somebody wants to debug, so how they can use that information of what happened.
One moment, please. Okay, how we can see something data in our blockchain? We need to write code to get that data from blockchain. How we can do this? Invoke SDK, extrinsic service. In extrinsic service, we have method which called get extrinsic status. We can provide here our transaction hash to get some data. We can get amazing count of fields where described our collection or our token or our transfer and more. I think that's all. Maybe questions.
Okay, that was very compact. Let me see if any of our listeners have any questions regarding this that we can dive into more details. Oh yeah, please explain two things if the questions don't come up. One is how do we top up once we have a wallet and an address which we used to create a signer. So once we have a wallet, how do we use the faucet to fill our wallet with Opal coins, because we need them for the transactions, because we have to pay for the transactions on the network. Can you show that?
Text, we can type a message start and communicate with bot. We need to provide our address, and after this bot transfer to us some value, and you can do any operations in Opal network.
So we'll be publishing this link, of course, in the information later on in both Discord and Telegram. The point being here is since you're working on the Opal network, which is the test network where you can develop applications and so on. If you were a part of the initial kind of chat we had, fireside chat on the Friday, we mentioned that the Opal network is the test network and the coin on it is valueless, which means that you can't exchange it for money on any exchange. And because of this, there is a faucet on Telegram, the unique faucet Opal bot Telegram, which will take in you give it the address of your wallet, which you created, which you will be using as a signer, and you ask the faucet to give you some money, and the faucet says, yeah, okay, here you go, I give you like few thousand opals, and now you can work with you can actually do the transactions. Otherwise, if you don't do that, when you do the transaction, you will get an error message saying that you have zero balance and that the transactions are not free, and you need to have some tokens in order to perform an extrinsic on the blockchain. There is a question. So there's a question, Stepan. Somebody asked, Nicolas Legna asked, would you please provide the Gradle library dependency links, the implementation links, because the documentation uses Maven. Could you throw some light on that?
I provide link after workshop to Discord channel or Telegram. You can see on link how to import a unique library by Gradle short or Gradle full.
Okay.
So, do you see my screen?
Yep.
Yeah, so we've got a small application here that I wrote today. It's a wallet app. It will show us how do we use Unique SDK in the iOS. So first of all, what do we have to start with? We start with our GitHub repository for Unique SDK for iOS. You can download it two ways, with pod Unique SDK or with packages. This is your decision what to use. And we've got here some small examples how to use our SDK, and I'll show some of them in my presentation, and some other how to transfer balance token you can see from our GitHub. So let's start. First of all, we have to set configuration for our Unique SDK. We import it and set configuration. So we are going to use Opal network. And for me to say all actions in our Unique SDK, it starts with the word unique. And you've got here all what you need, balance, fungible tokens, some works with collections, IPFS, and etc. So let's see at our application. First of all, we have to create a password. This password will be used to sign some transactions and extrinsics. So we just enter 1, 2, 3, 4. So this password is saved in keychain access, and it will save even if you exit the application and open it again. After that, we have to create our account. It's account for user. Let's name it some snake address later, like enter some your mnemonic from address, and after that pass here your address.
So remember, the mnemonic comes from your creating the wallet address through any of the means that you might use to create an address. The most common one is using the polka.js extension. This is where you get the mnemonic from, and this is where you pick up the address once you create it and use it for a signer.
Yeah, so we put here mnemonic, address, and name, and press save. So this account is saved in our applications, also in keychain access, and it will be loaded even if application is closed. So after that, let's go to the actions view controller, and we've got some different actions to see how does our unique network.
Maxim, I have to jump in because this is the first time I'm seeing iOS development. So I'll ask the question like I'm a developer sitting on the fence and looking at these things. The previous 3 functions, where are they actually connected? Where are the calls made on the previous screen?
Yeah, it's just on storyboard. So this create password, it links us to this screen.
And where are they defined? Where the functions that execute, where's the code that executes?
This just no code, it's just a interface do. You just have to pin a mark here to this screen and it will transfer us to this screen.
Okay. So that's about the interface, but when you're pressing the button like input password, there is a function call or somewhere in the background that you're processing?
Yes. Okay.
Yeah.
So when you put the password, we have a text that we've got from our text field, and we just use unique safe password.
Yes, that's what I wanted to see, because I wanted to see where the code that's happening is happening. Yeah. Right. Thank you.
Yes. And in account, we got the same unique account add account. And before that, we created a unique account variable. So also all variables, all models, they start with prefix UNK. So UNK cover pictures, text body, create token body, and something like that.
Yeah, UNQ,
so we added our account here. Yep. And we are going to our actions. So this is how we get the account that we saved. We just use unique account, log accounts, and here I use first. That's like the only one account I have. If you have several, you will choose like that. It's just an array. And
so that would be accounts from the wallet. Yeah.
So we've got 2 different functions here: build collection, sign collection, and submit collections. What do they do? The build collections, it just create the collections, and it's located in our SDK. So you can just build it, go somewhere, or make transfer to a new screen. It will be saved, and after like 5 minutes or how many you need, you can sign it. What do we have in the body of building collection actions? We have a mode. We just used NFT mode. We use some name, just some descriptions, some token prefix, sponsorship limits, and other properties that we don't need here, but you can use it.
So this is the minimum set of parameters, yeah.
Yeah. So this we put here our address where to collect collections, and do next. You use task do let result and try await. We're using async await in our SDK because if you don't and using like completion handlers, it is going to be a callback hell problem. So that's why we use async await here. And to build collections, we use unique collections, creations, build. In parameters, we use build parameters that stays here because they're the same for all requests or server, but you can write here something if you need. So let's have a look. Let's try build collections. This is the response that we've got. We've got a huge body of some properties, variables, and etc. And,
so to clarify, that's the response from the blockchain directly. Yeah.
Yeah. So this is a response from build functions, and this response we save in our property build response. It's a unique unsigned TX payload response. And when we're going to sign our collections, we are going to use this response that we saved here. So let's try to sign these collections. It asks for permission to allow to use a face ID in our applications. We press OK, and this is a face ID. It's a simulator, so we simulate as we matching the face. Yes, okay. So the face is matched, and we've got our new response from signing. And this response we save in our sign response. And when it's signed, you have to publish it in Polkadot blockchain. So you use submit collection functions. We've got a sign response here, like build parameters, and we have to create a body for this request. It uses the UNK submit TX body model. We put here a sign response, signer payload JSON is just a variable from our model. We have a signature also here that they signed our collection. And we put it here and make a submit.
So we were doing this also, if you remember, in the Android SDK, we use we're creating the body that we're submitting. And this is the similar case, yeah.
And we've got a hash here that we can check in our Swagger.
So you put it in the status.
Yeah.
Cool. Yep. And we get the status of the.
Yeah, but it says the extrinsic not found. That's strange. Why it happens? Okay, let's try something else. I don't know why it's not working, because it was working like 5 minutes ago. Maybe something with the rest.
Check if the copy paste of the string is proper. Maybe, yeah, no, it's okay. It doesn't happen. Yeah, that's the hash and that's the response.
Okay. Okay, so let's try just create collections with not using these 3 methods, with using only 1 method. So we're going to use like a typical body that uses in this first request. And we're just going to use submit watch. So it automatically builds, sign, and submit collections without using these 3 different methods. So let's try to create a collection. Yeah, face ID matched. Yeah, and we've got our hash. Let's try, maybe this hash will be working. Yeah, this one is working. I don't know what is the problem with the other hash. And after some time, it will be completed and we can see our collections. Yes.
There it goes. Yeah. So there you saw it, that this was interesting. The first response meant this is not yet complete. We were waiting for this. An extrinsic completed successfully, or an error message.
Yeah, and yeah, we can catch error here, and you can show it for user in UI as you want. And let's try to create a token for this collection.
Okay, so we picked up the ID there. If you caught that moment. So the collection ID was created the moment we created the collection. A new ID was generated, and we've picked it up here.
Yeah, and we just use unique. We write it here collections, but now we're using token, create, and also submit watch. So we're doing all these three things in one action. And let's try it. Yeah, now it says a collection not found. That's very strange.
Check again if you got the confirmation for the number of that collection in the collection ID 946. Yeah.
Let's try one more time. No, collection not found. Maybe it's some on the backend error problem. That's strange. Yeah, okay. Let's keep going. Let's see how do we upload our images to our wallets. First of all, we have to upload some image. I've got here images like monkeys, and monkey image. We'll upload it to our wallet.
That looks very familiar. That
yeah.
monkey.
So let's upload image. Yeah, we've got here from response our seed that was shown on Android SDK. This seed we're using to get our images from cloud and put it in our collection. So we saved this seed here, and now we just try to create collections with image. Matching face ID. Yes, and we've got our hash. To create a collection with image, we use collection creation submitted watch, and in body. Yeah, and in our body we have to use a schema. This schema creates like a unique collection schema to create. We put in the cover picture our seed that we've got from the past response. In schema image, we put this URL. This is a URL where we can find our image. So in this infix, in request, it will be put here our seed that is saved. It will be.
It picks it up automatically. Yeah.
This work is on the backend, so you don't need to worry about. And in schema name, we uses unique and also schema.
So yeah, one important thing before you continue. So let me just go one step back, because usually there's a question about this infix. Why do we use it, and when do you use it, and when do you not use it? So the infix, the way it's written here, actually is an instruction, which means please use the backend to insert the CID that we've given as a parameter, and it comes as a result from sending an image to the IPFS. So please insert it here in a proper way so it can be used. So you don't have to worry about the format. You just use this, and it automatically and automagically replaces it with the CID in the proper form.
Yes, and we can have a look. We have our unique wallet, and in this wallet there are some these collections will be posted. So let's have a look, and this is the collection that we created with this image of monkeys. So this method you can use in our hackathon challenge with QR codes and NFTs pictures. And
so 946 was the previous one. 947 was the one that we activated later on. I'm just following through with the numbers because it's important for the devs to understand that we are actually, since we're making calls create, that means 3 new collections will be created. We called them 3 times. The 946 one was the one that we were having issues with, but the 947 one passed easily through and was created. So I'm connecting the dots here. Now I have to make a comment before you continue, Maxim, regarding the schema. The schema itself is explained in detail in our online documentation, but you don't have to worry much about it for this very simple reason. What you see here is the minimal schema. The schema allows you to create NFT attributes that are very, very kind of useful for giving utility to your NFTs. If you want to use them, please look at the documentation on our website regarding how schema is formed. And also, I'd like to remind you that on the Unique Network YouTube channel, there are some workshops that show how actually you can manipulate this schema in an example where a collection was created with some specific attributes. Okay.
Yeah, and let's take our ID collection. It's 947, and what we're going to do now, we're going to post a token with image in these collections. To do this, we used to have to use a function create token with image action and put collection ID here, our collection ID 947. And also I figured out why it was not working, because I put a collection ID here, but don't rebuild the project. Sorry for that. And so now we are going to upload image monkey. To upload image, we use UI image name monkey that are stored in our assets. Here it is. Yes, and we just have to make the image to the data. So we use JPEG data compression with quality 0.5. And after that, we create a unique form data with file names that we want, like Monty2, also MIME time, GPG, and we put here our data that we've got with JPEG data function. And now we're going to upload our image monkey. Yeah, it's uploaded. We've got our seed here. And now we just want to create a token for our collections with the seed. It's like the same as we created collections. We just use image token body that we have to use. In this token body, we put image. These parameters you can see on our YouTube videos with the workshops. And with this collection ID, we just press create token with image. And let's see, face ID matched. And yes, we've got seed, our hash here. Let's check this. Yeah, it's completed, and let's have a look at our collection. Yeah, still don't have items. No, we've got. So this is the image we uploaded to these collections. And I think this is all that I have to show you. This is basic, and these basics, it will help you to win a challenge with our SDK.
Thank you, Maxim. That was perfect. Sorry, that was my phone interrupting your presentation. I had no idea that I had left my mic on at that point. So thank you very much. This is a very thorough presentation. I hope this is going to be helpful to everyone. It's a fantastic presentation, and both of you have absolutely presented a phenomenal step-by-step instruction of how you can set up and create a mobile application that uses the Unique SDK to actually create events on the blockchain.